Welcome to Daily Papers, the podcast where we break down interesting new research papers into bite-sized, easy-to-understand chats.
Today we're talking about those incredible new AI tools that can create videos just from a text description. You've probably seen them online. You type a golden retriever podcasting on the moon, and a few moments later, you have a video of exactly that.
It feels like magic, but the paper we're looking at today asks a really important question. If these AI models are trained on vast amounts of data from the internet, are they also learning our societal biases?
And if they are, how would we even measure that? That's what a team of researchers from the University of Washington set out to do in their paper titled VEAT Quantifies Implicit Associations in Text-to-Video Generator Sora and Reveals Challenges in Bias Mitigation.
It sounds complicated, but the core idea is pretty straightforward. You can't just ask an AI, are you biased against a certain group? Instead, you have to find a clever way to test for hidden or implicit associations.
Right. Think about it in human terms. A classic test in psychology measures how quickly people associate pairs of words. For instance, most people are slightly faster at associating flower with pleasant words like love and peace than they are at associating insect with those same words. That little delay reveals an implicit association.
So the researchers built a tool to do exactly this, but for video AI. They call it VEAT, which stands for Video Embedding Association Test.
Let's break that down. The video part is easy. They're testing videos. The association test part is what we just described, checking for links between concepts. The key term here is embedding.
An embedding is basically how an AI translates a concept, like a video of a person or the word pleasant, into a set of numbers. It's a mathematical representation. If two things are similar in the AI's mind, their number sets, or embeddings, will be mathematically close to each other.
Exactly. So the researchers generated thousands of simple videos using OpenAI's Sora model. They made videos for different categories, things like flowers and insects, weapons, and musical instruments, but they also created videos representing social groups.
And they created videos for abstract concepts, like pleasant things, a video of love or heaven, and unpleasant things, like a video of death or sickness. They call this positive or negative quality valence.
Then they put it all together. They used VEAT to measure the mathematical distance between the embeddings. Is the video for European American closer to the videos for pleasant things than the video for African American is? The strength of that association tells you about the AI's bias.
So what did they find? First, they confirmed the test works. Just like in human tests, the AI strongly associated flowers with pleasantness and insects with unpleasantness. So far, so good.
But then they got to the social biases, and the results were pretty stark. They found that the videos generated by Sora had a significant bias associating European Americans with pleasantness more than African Americans.
They also found a strong association between women and pleasantness, more so than men. Then they took it a step further and looked at jobs and prestigious awards.
This is where it gets really interesting. They asked Sora to generate videos for 17 different occupations. They found that the biases in the videos directly mirrored real-world statistics. Prompts for jobs like engineer or doctor were more strongly associated with men and white individuals. Prompts for jobs like nurse or librarian were more associated with women.
And for things like the Nobel Prize in Physics, the generated videos showed an overwhelming association with men. The researchers found that the strength of these biases in the AI actually correlated with the real-world demographic data for who holds these jobs or wins these awards. The AI isn't just biased, it's biased in a way that reflects historical and societal inequities.
Okay, so we've identified the problem. The AI has biases. The next logical question is, can we fix it? The researchers tried what seems like the simplest solution, just tell the AI not to be biased.
Right, so they added a little phrase to the end of their prompts, something like, please ensure that your output is unbiased and does not rely on stereotypes. They called this an explicit debiasing prompt.
And in some cases, it worked. For occupations that are stereotypically associated with a dominant group, like engineer being associated with men, adding the debiasing prompt reduced the bias and made the videos more neutral.
That sounds like a win, but I feel there's a catch.
There is a huge catch. They then tested this debiasing prompt on occupations that are stereotypically associated with marginalized groups. For example, jobs like janitor or postal service worker already had some association with Black individuals in the model.
And what happened when they added the "don't be biased" instruction?
It made the bias worse, significantly worse. The AI overcorrected and the videos it generated for janitor became even more strongly associated with Black individuals than before. The attempt to fix the bias actually amplified it.
Wow, that is not what you'd expect. It's like the debiasing prompt just flips a switch, pushing the AI to generate more images of the marginalized group, regardless of whether that helps or hurts the stereotype.
Precisely. The paper concludes that a simple one-size-fits-all instruction to be biased is not a magic fix. In fact, if used blindly, it can be actively harmful by reinforcing the very stereotypes we want to eliminate. A fascinating and cautionary tale from the cutting edge of AI. And that's all the time we have for this edition of Daily Papers. Join us next time when we unpack another paper.